welcome to the Latino STEM Alliance and Boston Public Schools Office of Instructional and Information Technology webinar series, Step-by-Step Programming with your EV3 robot. This is the fourth and final webinar tutorial for sensor use and programming basics to prepare you for our game challenge and competition towards the end of this May. As before, you will need your built robot and EV3 software application open to actively participate with the live webinar, as well as signing on to the back channel to post questions. Today, we will review the game challenge for the competition, the robot educator, and other features of it on the educational software, as well as sensor review and more sensor work. Now I'll turn it over to Haruna and Dave.
The game this year is called First Response, and it is meant to simulate or sort of replicate the situation of being in a disaster type response. So the game will involve debris to clear and civilians to rescue. So just a quick overview, we've got the field here. As we have in previous years, it's going to be two fields, which means two robots will be competing simultaneously for the competition. But when you have your practice field at school, you'll only have one half field because that's all you'll need for practicing. Here's a closer look at dimensions of this field. It is roughly 4 feet by 4 feet. You've got your three different lanes of varying width, the middle lane being about 15 inches, the two side lanes being 13 inches, and those black lines are about 1 inch thick. And then your starting zone is 12 inches deep, and your, we call them the starting zone is the safety zone, and where the civilians go, oh my gosh, is the rescue zone. That's right, it's on the next stage. I'm jumping ahead of myself. And those are about 8.5 inches. So that's something to remember for dimensions of your robot. It needs to fit in that starting zone and in the civilian zones. So the smallest one would be the yellow and red civilian zones, which are about 13 inches wide and 8.5 inches deep. As long as you have two wheels in that zone, it counts as being in that zone. And we'll explain why that's important a little later on. So the normal match time is going to be 2 minutes long, so robots will have 2 minutes to perform as many activities during this match as they can. As usual, is completely autonomous, no remote-controlled robots. They can run as many programs as they can during those 2 minutes, but all programs will have to start from one of these zones that the robot is allowed to be in. And those would be the start zone and the 3 rescue zones that are yellow, green, and red. So this is different from other years. Normally, you could only pick up and manipulate your robot and game pieces if they're in the start zone. But this year, that's true for the start zone and the rescue zones. So that means that if your robot stops in the start zone, you can pick it up to start another program, place it back in the start zone, and run it again. Or if it stops in the red, yellow, or green safety zone, rescue zones, you can also pick it up, change a program, and then place it in that same zone. So you can reposition it within the zone, but once you lift it from the yellow zone, you have to put it back in the yellow zone in order to keep running. So activities to do, there's debris and civilians on the field. You can see the 3 dots on the white lanes. There's a yellow, green, and red. That's the debris, and those will be standing up wooden dowels. The wooden dowels are 1 inch in diameter and about 6 inches tall. And you'll have to knock that over, and that counts as clearing the debris before you can actually rescue the civilian from the rescue zone. Yeah. So that means that if your robot stops in the rescue zone and the debris is still standing up, you will not be able to pick up that civilian. And civilians are also, just so you know, they're 1 inch cube wooden blocks. So here's some of the rules, some of which I've gone over already. Let's see. So civilians can only be moved once the debris is cleared, and zones do include the tape that surrounds them. So for example, the start zone has the red tape, the red lines on it. If your wheel is on that red line, it counts as the start zone. Okay, so there's an explanation of the game pieces again. There's going to be 3 civilians, 1 in each colored zone. That's a 1 inch cube, and then 3 pieces of debris that will all be 1 inch in diameter around dowels that are 6 inches long. So in order to get points in this game, there's 3 different things you can do. Knocking over the debris not only allows you to start rescuing the civilian, but counts as 2 points. So for every piece of debris knocked over, you get 2 points. And then rescuing the civilians. Once your robot is in that rescue zone, you can pick up the civilian and the robot, place the civilian somewhere on the robot, and then try to drive back to the start zone. If the robot comes to a complete stop in the start zone with a civilian on it, that counts as 2 points. That civilian has been rescued and will be taken out of the game. Similarly, you can also try to clear the debris. So if debris is brought to the start zone, either being held by the robot or come to a complete stop on the floor of the start zone on the mat, then that also counts as 2 points. So it's 2 points for each piece of debris cleared by knocking them over, 2 points for each civilian rescued by bringing them back to the start zone, and then 2 points for each piece of debris cleaned out, which means returning those also to the start zone. And there's an end game bonus as well. If your robot has at least 2 wheels in that green rescue zone, once the timer hits 0, then you'll score an additional 3 points for the round. Penalties, every penalty is basically a 5-second wait, and that will happen if your robot somehow gets into the other player's field, tries to roll off of the field, or it comes to a complete stop, meaning the program ends in one of the white lanes. So if it stops and it's not in the start zone or any of the rescue zones, then you have to wait 5 seconds before you can pick up the robot and start it again. And no matter where it came from or where it ends up stopping, it has to be returned to the start zone after that penalty. Just to go over some strategy, that debris, they are wooden dowels. They are, I said 1 inch in diameter, they are round and they will roll. So knocking them down causes this random piece of debris to be on the field that may interact with your robot in a number of different ways. It's very hard to predict what will happen. So one thing to think about is how you want to hit that debris in order to knock it over. Approaching it from different angles, that'll let you use different ways, might be advantages. Those are some things to experiment with and see what you think is good. Also, figure out what you think is most important. Have your students discuss if rescuing the civilians or completely cleaning up the debris is more important, and that's based on what they think might be most achievable. Some fundamentals for this game would be recognizing the walls. The walls are always there, they're always in the same spot, so they can be useful to try to figure out how far you've gone or once you've reached the right point, as well as recognizing the lines. There's lines between all of the lanes, so that can help robots realize once they've reached the next lane when they want to start turning. And also path planning. Since you can now start your robot from all the different zones, you might want to figure out if you want to, let me back up, say start in that start zone, go to the yellow, and then go from yellow to green, or go back to start from yellow. So there's a lot of different options here. And while that is good for strategy, it's something that could become confusing for programming. So whenever any program is written, you really want your students to take note of what zone the robot is going to start in for that program, because that will make a huge difference. For building aspects, you need to think about transporting the civilians and moving the debris. So once your robot is in that rescue zone, you can just pick up the civilian and place it on the robot. That's easy. You don't have to worry about picking up the civilian, but you have to make sure it stays on the robot. So maybe building something to cradle or hold a 1 inch cube might be advantageous, as well as moving the debris. Do they want to roll the debris? Do they want to just knock it over in a controlled way, or do they actually want to pick it up and carry it? Something that's worth mentioning is that the rule states that anything in a rescue zone or the starting zone can be picked up and manipulated. So if students can find a way to move debris to the rescue zone, they can then pick it up and place it, so we don't have to worry about picking it up, but they still have to worry about carrying it.
Okay, so we're going to go over the Robot Educator, and these are some things that may help you understanding the basics and to prepare for the competition. So I will go over specific things that I think are related to getting you rolling with your programming. So on the left-hand menu, it's the bottom, and it says Robot Educator. So the basics. The display for any of the categories is going to show you the most simplest concept down to the most difficult and challenging concept at the bottom. So just keep that in mind. The first thing I'm going to go over is the tank move. You can steer the tank as well, but we tend not to do that. We use the tank move. more often, so I'm going to go over that. So there is a video to watch. I won't play that now. You can watch the video, and you can see from the screen the 3 circles. So I'm going to show you a program, and it's going to describe how to make a tight circle, how to make a bigger circle, and how to make a half circle. So when you open it, on the right is sort of the manual for each action that it's showing you. Let's see. So when you highlight it, I will highlight it here. So this describes the first movement. So this is showing a tight turn, which you have done at your sites. Motors B and C at a positive power of 40 and the negative power of 40. We've done this many times. So this is, it can reinforce these simple things, the weight block. I'll show you again. So when you hover over a command block, it will play the video. After it shows you a sample for the programming of the specific move or command that they're showing you, you can have the students test it out themselves and try and copy it, tweak it a little bit, and follow the directions. It's not necessary, but so that's how each area of the robot educator is set up. So move tank is a great one. Moving an object could also be helpful. It shows the cuboid like you built with your robots. This could be helpful to start your program for moving the cylinder debris, possibly. And I believe this is set up on an intranet, so you don't need the internet to use this feature. So again, it's the same principle. And I'm not sure if you are familiar with, if you hover over the pictures or hover onto the block, it will tell you what's going on. So the students can learn and reinforce what's happening. So there's an example of movement with the medium motor, which could be helpful for the competition. So I will close out of that. To close out of it, you just exit just like anything else. Brings it back to the menu. And stopping at an object is also something that could be helpful as well. I won't go through that one because we've already gone through 2, so that should be sufficient for that. So the Beyond Basics has some more of the programming concepts. What I wanted to show you, the students can go through the loop if they like also. That's also a helpful one. I'm going to show you the switch because the switch is it's actually what we did on the webinar, the second webinar with following the line. So this one is the line follow. And also within the little booklet, if you see the blue, obviously the line, something underlined with the blue, you can reference and click on it and find out more information if you like. So this is the line follow program. And just as before, if you click on it, it will show you what's happening. I find this larger display helpful. It can kind of help the concept sink in of what's happening here, that the motor is going over to motor C, checking for the difference in the value and the light values, and then it moves and that turns off or on depending on the conditions, and then it moves over to the other side to motor B. So the nice big display can help absorb the information. It does for me anyway. So I found this very useful, and this is a perfect accompaniment to the second webinar. Also, there's a feature that's neat. We won't go into it this year, but there's also other things you can do within these little tutorials. You can change conditions and experiment, and that has some graphics with it. And you can save programs here as well. So that's definitely a good one to go over. And then there's the multiple switch as well. So once you get into if-then scenarios, that can be helpful to reinforce how samples of how it's done. So up here under the tools, and I think Haruna is going to go over this as well. Here is one place where you can find how to update the robot brick. I think they are sending off signals that the robot, that the brick needs to be updated. The brick is a computer, so it does need some updates. So if you click on that, it will run through how to, the process that you have to do to update.
But usually you won't have to do that unless you're prompted to do so. So if you once you connect your brick to the computer and you get a pop-up saying you need a firmware update, that's what we're talking about.
Yes.
So unless you get the pop-up, you don't have to worry about this.
And it has come up at some of the sites too.
Yes, so when I changed my program from the retail version to the education version, I got the pop-up.
Yes.
So I'm expecting some schools to get it too.
Yes, they have.
And it takes about 5 minutes.
Yeah. And I told them to look it up on their phones how to do it. That was my answer. So on the top menu bar is another wonderful resource to find how to do things. And let's see, so if we go into show EV3 help. So now this is a very helpful search tool. I love this, it's great. And the help here is different than the help when you're going through in the robot educator. I think this one is much more user-friendly and gives different examples as well. I like the examples that they give here because it does start again from the basics and goes down the line to the more complicated examples, but it's very useful. So under the general help, and we want the students to be doing this on their own and finding out their own information. So this is definitely something for everyone, for me, for facilitators, but especially for the students. So the first thing I'm going to show you is using the sensors. We're going to the ultrasonic sensor.
And this help menu opens up in a browser, but it is on the computer. It's local, so you don't need an internet connection to go through this.
Yes. That's very good. So this is all the details you could ever want to know, that I would want to know about the ultrasonic sensor. And there's a useful tip I read down here. It says that objects that are rounded are harder to detect with the ultrasonic sensor. That applies to the game and the debris. So that's something to take in. Just as the other tutorial section, this also has different examples, which are wonderful to read and make a lot of sense. And then down at the bottom, there's a chart, a table of how the ultrasonic sensor can be used with each of the flow blocks. So that can be useful as well. So that's just one example of, how they display the information. The same menu is over here on the left, so access. The next thing we're going to go, just take a look at probably the flow blocks. But again, the motor rotation has some great information in there as well. And under the general area programs, they also have very helpful information and data wires. I won't go into either of these, but they're definitely useful for reading up on, if you're using the sensors, you may want to use a data wire. So these are all useful tools for you to explore or generate questions for Dave and Haruna and the others when they come out to your sites. The loop is in here. It gives a good example or description of what a loop is. This is a simpler explanation here than in the basics where they also have loops. They were explaining some crazy things which I didn't understand. This explanation is much better. I like this for general information if you want to start from ground zero. It also it's a very good place to read up on the switches as well. And just as in the other example, they have examples. True and false. So the next thing, so that's it for the robot educator. The next thing I wanted to go over was the MyLab. So the MyLab is a Google website that is going to be the place where we will store our videos, audios, pictures, your discovery and artifacts and everything that you're learning, and the videos you may be taking with your phone that we have not posted anywhere yet. So this is the Google site where we will post them. And just a special note, we are still getting the mechanics of this, how you will get the information off of your phone up onto the sites the easiest way possible. We will extend the first semester pizza party until the end of February. So for those of you that were with us last year, this is the same thing basically as the blog site last year, to write down what's going on at your schools. So that's the main site. I just kind of whipped through that. But. So you just pull up your own site, your school. There should be enough teams so that you can assign a team to each group, and they can go in and rename their team, and they can post pictures and videos.
And how would the facilitators log in?
They can sign in. Let's see. We have a Google email account for it, so they can sign in through that. So we have a Google email for MyLab set up, and I'll send out the password. When you sign in with the MyLab password, that enables you, the students will be able to edit and insert videos and insert comments, make a page. I'll try it again to pull it up. Let's see. I guess I did it. I know. So there should be an edit button here, but there's not. This is the MyLab site. But if you're familiar with any Google site, over here on the right, there's the insert button. So you can also link your videos and such. Maybe I'll try to sign on in the end with the MyLab information once I get the password. But for now, we'll probably just move on to the rest of the webinar.
So we want to go over some things about the sensors and how to view the values of the sensor. But before I do that, I want to show you something I ran into while I was doing the firmware update. So earlier, when I changed my EV3 software from the retail version to the education version, I was prompted to update this firmware. So I went up to Tools, I went to Firmware Update, and updated the firmware. Now, after I did that, down on this window on the right side bottom, where it shows the EV3 status, I wasn't getting a status. It almost appeared like the EV3 was not connected to the computer. And it turns out there are different modes when the EV3 to be in. And right now it's in the EV3 mode, which is what I want. But when I did the firmware update, I got another line on the screen here that said firmware update. And once that was selected, the EV3 behaved like it wasn't connected. So I had to go into this tab right here that says available bricks, click on the EV3, and then go back into the information, and I can see the EV3 again. So some of you may run into that issue once you do the firmware update, so I just want you to be aware of that. And then while we're in this window, I can also show you how to see your sensor value. So in the second tab where it says port view, once you click on that with your EV3 connected, you will see all of your motors that are connected, as well as your sensors. It automatically detects what kind of sensor you have, and the flickering number you see on the top is the actual value that the sensor is reading right now. And right now I have an ultrasonic sensor on port 1, reading centimeters. I can select inches if I want to. And Dave has his hand in front of the sensor, and now it is at 16 point something centimeters. There's also a way to do this on the EV3 screen. So we will show you that as well. So now you're looking at my EV3 screen, and Dave is going to navigate to show you how to see the sensor value right from your screen.
So I'm just going to be using the left and right buttons to sort of navigate right now. At the top, you've got the 4 different icons. We call those the tabs. And we did mention earlier that the second one that looks like the sheets of paper is where your programs are. If you push to the right to the third one that has the 6 squares, there's different options here. And the first one is what we use called port view. So you push up and down, the up and down buttons. I'm trying to go too much with the screen here, to select that, and then hit the middle button once port view is highlighted. I hit the camera to select port view.
Reflection is awful.
Yeah, the glare is kind of, yep, so that says port view. It's the first option there. And we hit OK to select that. That might be better.
That's better.
When it's
Okay,
like
let's
that,
do that.
So you've got the central part of the screen here, which is showing information. It's showing, you can see a picture of the ultrasonic sensor, and again, that number, let me put my hand in front of it, will tell you the distance that it sees. So what you can see is at the bottom here, it's showing that it's looking at this first tab. And we can actually push left and right to go through the different tabs and see what else is in. So these 4 bottom tabs correspond to the 4 sensor ports. The first one being port 1, and then port 2, 3, and 4. Right now, we only have 1 sensor plugged in, which is the ultrasonic sensor, into port 1, which is why when we go to ports 2, 3, and 4, we see nothing.
And it should automatically detect what kind of sensors you have. But if it's somehow not seeing it, we just suggest you to turn off the EV3 and turn it back on to see if it can detect it that way.
And then there's also 4 tabs across the top. So if I push up, it switches to looking at the tabs across the top, and these are the 4 motor tabs. So here we only have motors plugged into ports B and C. So the first one, port A, shows nothing. Port B shows 1 motor, and then port C shows information for that other motor. So what we can do, once we have one of those ports selected, I'm going to go back to the ultrasonic sensor, is hit the middle button to select that sensor, and that provides us with options. So we have distance in centimeters, distance in inches, and listen. I'm not sure what listen is for an ultrasonic sensor. That might just be, that's probably just detecting an object, yes or no type thing.
Something like that.
So you can actually switch between the units that you're actually looking at. We were looking at centimeters before. I'm going to try listen. All right, well, we don't know what listen is. But there's centimeters and inches there, which is useful because that's what you'd be programming with when you're using the ultrasonic sensor. So now, let's say you're on the field and you know there's a certain point where you want your robot to turn. You know it wants to turn at that specific spot. You can place your robot at that spot, set this on your brick to actually view what the sensor sees and see, for example, what distance the wall is from the robot with the ultrasonic sensor at that spot. Now you know what distance you want to set to when you're programming. So this is a quick way to see what your sensors are seeing for calibration for your sensors. It can also be used once you get the field to look at the different light values that the robot will see on the white or black spots on the map, which will help with programming as well.
Another useful thing is with the motors. So when you're up in the motor section, it tells you the rotation in degrees or number of rotations. So now I just moved the robot a little bit. Now it's at 45 degrees. So if you know that you want the robot to travel from a certain spot to another spot, you can roll the robot by hand while you have it on port view and see how many degrees that it corresponds to, so that when you program it, you have less trial and error. You know exactly how many degrees you need to travel.
Yep. So we've shown before how to see the sensors on the computer, but this is a great way of doing it without having to plug into the computer, which can save some time when you're running back and forth between the field and programming.
And we're going to talk a little bit about how to use sensors in a slightly more advanced way. Do you want to talk about that, or?
Sure, I can. How about I try and you correct me if I start missing something. So a lot of times when I do site visits, students would tell me that their sensor blocks weren't working, and they were going to this yellow tab and picking sensors from here and trying to use them like the wait commands. And I would basically just tell them go back and use the wait commands. So today we'll actually explain what these yellow blocks can be used for. This yellow tab is called sensor. It's literally just sensor. There's no wait, there's no switch. It's just looking at the sensor itself. And you've got all the different sensors here as well. So let's just pick ultrasonic as an example. So I'm going to drop this ultrasonic sensor block onto our program. And it automatically detected port 1. That was nice. And just like before, you can set to measure or compare. In this case, we're going to do measure. So this block really tells the robot to do one thing, and that's read the sensor value. And that's it. It's not telling the robot to do anything at all with that sensor value rather than look at it. But what we can do is start using the data wires, something that was mentioned earlier by Sarah, to actually take that sensor value and use it as an input for something else. You'll notice this output here, this little block is sort of known as an output. Once you mouse over it, your cursor turns into a little spool with wire coming out of it. So that's telling you that it's ready to wire. So what we can do is move on to the advanced tab, the blue tab here, which has a whole bunch of functions that can be interesting, but we're going to look at just unregulated motor for now. Do you usually use the green drives or this unregulated motor?
No, I just do the green drives.
You do the green drives?
Yeah,
okay.
Rather than the power, we just...
Okay, maybe we'll stick with this then. So I'll drop down a move tank command here. And do you still use duration? So this would
what we're doing.
Yeah, okay, so we'll stick with duration for now, I guess. So normally we would dictate this motor power by just typing in a number here. But if you notice, all these different inputs have different shapes on them. This one has a round end. This check mark here has a sharp end. The output here also has a round end. What that means is that this output could actually plug into one of these inputs. So if I click and drag that sensor output, you notice that that shape follows with me. And then I can drop down onto one of the motor inputs. So what does this mean? This now means that the robot is constantly reading this sensor value and using it as the power of this motor. So before, when I had my hand in front of the sensor, we saw about 16 centimeters. If the ultrasonic sensor saw something 16 centimeters away, that means this would move at a power of 16. So why don't we wire both of them to the same thing? I'll get both motors to run at a power of 16. Well, not 16, at whatever it sees.
It's probably better if you just do on rather than doing the duration.
Okay.
And then
So yeah, okay. That's what I was, now this works. So one thing to note about both of these, like Karuna just said, we switched from on rotations to on. Now neither of these things has a duration, which means if they were both just there, you'd run the program, it would just, one instance of them would happen, you'd see it jerk forward for a tiny bit and then stop. So we actually need to put these into a loop so that it'll keep doing this over and over again. So right now this program, the loop is running unlimited, which means it'll keep going until we tell it to stop. And the motor power value for both motors will be exactly what value the ultrasonic sensor sees. Should we download this and demonstrate at this point? Distance drive. So we have a name. Okay, and this is already plugged in. Yes.
All right, let's switch to the camera view again. Then I'll put a wall. Can you point it towards that? So this.
Can you see that?
Yes. Well, maybe not. Okay,
Okay,
so we have
there
a
we can
wall
see
on
that.
the right-hand side and a robot going towards the wall.
So why don't we run it and then explain what happens afterwards?
Yep.
You can hear the motors running. All right, so why did it do that? Like we said, with the program we just wrote, the sensor value is going right into the motor power, which means whatever distance that sensor sees is what the motor power is. So we saw it drive forwards, but then get slower and slower because the closer it is, the smaller value the sensor sees, until it gets close to 0, which is where we heard the motor whining and it not going anywhere because it wasn't enough power to actually do anything.
And something like this is really useful if you're using the robot in a game and you don't want it to crash into a wall. You want to stop somewhere in the vicinity of a wall, but you don't want it to jerk to a stop or crash into the wall. So you can have it slow down as it approaches the wall and come to a nice, clean stop.
Mm-hmm. But with the way we're working right now, it's only ever going to come to a complete stop when the sensor value sees 0.
Correct.
And there are some things we can do to change that.
Yes. And Dave's going to show you that now.
So I'll start by unplugging these. Right now we had a direct route. Is the screen switched?
Yep.
Okay, cool. Thank you. We had a direct route going from the sensor value into the motor powers. But what we can do is actually add some logic to the sensor value before it goes into those motor powers. Basically just do a little bit of math to the numbers. So for now, I'm just going to unplug. If you ever want to unplug something, just click where it's plugged in, just drag it out to nowhere, and it'll go away. So the red tab is known as data operations. And there's a lot of things going on here. The one thing I'm going to mention right now is the math block, which can be very useful. So I'm going to take a math block and actually drop it between the two blocks we have already. So you see here the different options for the math block. You've got the plus sign. So we can actually decide if we want to add, subtract, divide, multiply, or more stuff. Oh, I forgot there's absolute value and square root in here. Cool. We're going to stick with adding and subtracting for now. Which way do I want to do this? We want to subtract for now. Yeah. Great. So after you choose the operator, you've got three other options here. Now these shapes again suggest that these are inputs. You could make them numbers just by typing it in like we did before, or you could actually plug something into them. And the last thing, as the equal sign, is the output. So right now we have subtract 1 minus 1, which would be 0. So the output would be 0, which is the same thing. But what we can actually do is wire one of our sensor values as one of the inputs for the math operator, and then change the subtract value to whatever we want. So right now, let's say we want that robot to stop. Actually, let me do the last wiring before we start changing that number. So what we can do is take the output of that operation and plug it into our motor power. And for the sake of this, I think we want both motors to be the same power, so we're driving forward. So whatever the answer to this math equation, we have the result is going to be the output and input as both motor powers. So now we've got two steps. We've got the raw sensor number, a subtraction operation happening to that number, and then that result will be the motor powers. So right now, if the sensor reads 16, the motor powers will be 15. So why is that significant? I'm going to change this to, let's say 12. Now that this is 12, that means our motor powers are going to be whatever the sensor sees minus 12. Why is that important? Well, the big thing is to say, when are the motor powers 0? And in this case, the motor powers will be 0 when the sensor sees a value of 12 centimeters. So at 12 centimeters, 12 goes in here, 12 minus 12 is 0, so your motor powers are 0. So that means that the robot will come to a complete stop when it is 12 centimeters away from the wall. And that's a way to use this sort of math operation with the raw sensor value. And then we'll show another instance of what happens with the wall afterwards, but let's just download this for now and then run it.
And that's also supported in the robot educator, I believe, stopping at an object. That's also explained there as well.
All right, so here's the robot again. Here is the wall. I made the wall a little bit easier to see this time.
I need to refine the program. Distance drive. Okay. How's that camera-wise?
Yep, that's good.
Good. All right.
So right now it's about 35-ish centimeters from the wall.
All right, so let's run this and see what happens. Great. And we hear slowly we're to a stop at about 12 centimeters away from that wall.
Wait, can you run that again? The video was doing something weird.
Sure.
The video seemed to have jerked a little bit, so we're going to rerun the program.
So just like before, it gets slower and slower as it gets closer to the wall, but this time, because of that minus 12 function added in, it stops at 12 centimeters away from the wall.
And if I move the wall, it starts moving again. And actually it'll move backwards too if I get the wall closer.
Right, and that happens because if the input is less than 12, then you've got a negative power for your motors.
This is kind of fun.
It is. It's pretty fun to play with. It's almost distracting sometimes. It kind of makes me wish we had more of a dynamic field so people could do more stuff with this. But that would be expensive.
Okay.
But this is a great way to show how you can use these sensors to really interact with the dynamic environment and do some fun things with these robots.
All right, can you turn that off so I can let go of this wall? Thank you. Is there anything else you wanted to mention about the sensors?
Yeah, just one more quick thing, just to play with, is we showed how you can use this subtract here to smooth what I'll say is sort of the baseline to change when that motor power is 0. Something else you could also do, this might be too complicated, but I'm going to show anyways, is adjust the gain of the sensor as well. My voice is telling me I shouldn't be explaining this apparently. But if you take the output of this, move it to another block and switch it to multiply, now you can sort of change the speed that your robot moves at. Because before it was a 1-to-1 thing, 1 centimeter changed the power by 1. But if you multiplied by 2, you would see the robot start a lot faster and also slow down at a more abrupt speed. So that's something that's really, it's fun to suggest, but it's tough to explain exactly, but it's worth exploring how multiplying that sensor value by a number and plugging that into a motor power can be interesting. That's all I really had for math operations.
Do you want to demonstrate that, or?
Yeah, let's exaggerate it.
All right, so this is with the exaggerated.
Yep, so it's the minus
Further.
12 and then times 5 on the value.
So if the robot is 20, well, not 20 centimeters, like 32 centimeters away, minus 12, that gives you 20. Before, it would have gone at 20% power, but now that would get it at 100% power.
So the same thing, but a whole lot faster.
It's much more responsive because of that.
And you can do the same thing with divide to have a much slower approach if you want something a lot more controlled. So sometimes you might only want to use multiply, sometimes you might only want to use subtract, but it can be fun to use both. It can get a little confusing sometimes, but just remember to do one operation at a time into each other, and it shouldn't cause too much trouble.
I do want to add one last thing to that program.
Okay, I'm out of voice, so you have to.
Let me share the program again. So right now, once it's in an infinite loop. So once it's in this mode, it stays here forever. But if you were using this in the robot game and you wanted to do something after it gets to that wall, this infinite loop is going to be pretty useless. So what you'll then have to do is, rather than doing an unlimited loop, you have to do some other loop so that it kicks you out of the loop at some point. Since you're already using the ultrasonic sensor, that's probably the easiest thing to use. And you can say something like, when the ultrasonic sensor sees a number that is less than, what was that? We want it to stop at 12 centimeters. When it sees something less than 12, stop, or not stop, but kick yourself out of the loop.
So it'll never see something less than 12 on stationary stuff.
That's true. Because so it actually will pretty much never get to that number, the 12, because once the power gets so low that it's very close to 0, it's not going to be enough power to move the car.
It approaches but never gets.
So it will probably never approach 12. So we can put in something more like 15, and that's when the car will actually stop. So whenever you're doing this, you're gonna have to experiment a little bit more on the field.
Do you want to add a turn function after the loop to show that it gets to the end of the loop?
Sure. Oops. So let's say when it gets to less than 15, it will come out of this loop, and I will put in another move tank. To do a little turn. All right, so let me download that. So there's the robot. So now when it got to 15 centimeters, it kicked it out of the loop and did a little turn.
But we could see the loop was still useful because it had more of a controlled approach as it was slowing down.
Yeah, we still have the 5 multiplier in there, so it's a little bit abrupt. But.
Cool.
All right.
So we thank you for tuning in to today's webinar, and we strongly recommend that all sites watch or view the material covered in the webcasts, particularly sessions 2 through 4, prior to the site visit starting after February vacation. And we'll continue to work towards the presentation project and submitting the videos to MyLab. And we will continue to accept submissions until the end of February for that. So again, we thank you for tuning in, and good luck with your programming and game strategies. Dave, Haruna, and the other engineering experts will see you after the break at your sites. So thank you.